If you look at a standard globe, the rules seem simple. Rivers flow toward the ocean, continents are made of solid, dry land, and gravity ensures that waterfalls always fall down. But geography rarely plays by the rules we learn in grade school. At the cliffs of Moher in Ireland, or along the coast of the Faroe Islands, severe coastal winds can blast falling water right back up the cliff face, sending the entire stream spraying backward into the sky. Deep in the Peruvian Amazon, the water defies a different set of expectations. This is the Chennai Tempishka. This river runs at nearly 200 degrees Fahrenheit, hot enough to cook any animal that falls into its current. The nearest active volcano is 400 miles away, leaving the source of this thermal energy as an anomaly in the middle of the jungle. These environments reveal that our mental map of a static, predictable Earth is an illusion. The surface we walk on is a highly active system, full of physical contradictions that ignore the standard rules of nature. Some of these contradictions go deeper than surface water. While we experience gravity as a constant force holding us down uniformly, it actually fluctuates depending on where you stand. Around the Hudson Bay region in Canada, the Earth's gravitational pull is measurably weaker than in the surrounding regions. During the Ice Age, the Laurentide ice sheet compressed the crust downward, creating a massive indentation. The ice melted millennia ago, but the crust is still bouncing back. With less mass in that depression, the area generates a slightly weaker localized gravitational field. While a lack of mass creates invisible pockets of weak gravity, extreme topography can hijack our physical senses. Off the coast of Mauritius, aerial views reveal what appears to be a massive waterfall plunging beneath the ocean surface. This animation shows the actual mechanics. Ocean currents are pushing heavy sand and silt deposits over a dramatically steep drop-off in the coastal shelf, pulling the sediment into the abyss to create a perfect optical illusion. Between compressed continental crusts and steep oceanic shelves, Earth's hidden topography has the power to trick both our most sensitive scientific instruments and our own eyes. If the physics of the planet are deceptive, the physical boundaries we draw are just as fragile. We define a landmass as a piece of Earth surrounded by water, but nature often layers those definitions. This map of the Philippines shows a rare fractal topography. Vulcan Point sits inside Crater Lake, which is located on Taal Volcano Island, which sits in Taal Lake, found on the larger island of Luzon. These nested boundaries exist at a small scale, but the ocean conceals an omission far larger, an entire continent. Zealandia is a massive, officially recognized continental landmass, twice the size of India. Around 85 million years ago, it fractured and broke away from Australia. 94% of this landmass is submerged beneath the Pacific Ocean. Only its highest mountainous peaks, places like New Zealand and New Caledonia, break the surface. These submerged reaches prove that true geography is dictated by the massive tectonic plates shifting below, regardless of whether they are exposed to the sky or drowning in the Pacific. When we look at how elements move through these hidden topographies, the behavior becomes even more chaotic. Deep beneath the surface of the Black Sea, a massive river system flows entirely out of sight. It features its own waterfalls, carved riverbanks, and rapids. The volume of water moving through this trench is so immense that it would rank as the 6th largest river on Earth if it were located on the surface. High-density, salty water from the Mediterranean pours in and plunges straight to the seafloor, racing rapidly along the bottom beneath the lighter, less dense water of the Black Sea. While dense water traps rivers beneath the sea, trapped gas creates a different kind of chaos on the surface. This is the Darvaza gas crater in Turkmenistan. In 1971, Soviet engineers accidentally punctured a massive underground natural gas cavern. They set the leaking crater on fire, expecting the fuel to burn out in a few days. More than 50 years later, the fire is still burning. Thousands of miles away at Lake Maracaibo in Venezuela, the sky is trapped in its own cycle. This image captures the Catatumbo lightning and nearly permanent electrical storm. Trade winds constantly blow warm Caribbean air directly into the towering ridges of the Andes Mountains. This collision traps the air masses, creating the conditions for up to 28 lightning flashes every single minute. Whether it is dense salt water, pressurized natural gas, or trapped atmospheric currents, Unique topographies force elements into perpetual loops of energy that refuse to follow standard natural cycles. These anomalies are the visible, grinding gears of a planet operating on the scale of deep time. The Earth is a shifting engine, and its features are in constant flux. Mount Everest, the highest peak on Earth, is currently growing several millimeters taller every year. The Indian tectonic plate continues to crash into the Eurasian plate, forcing the crust upward and driving the peak higher into the atmosphere. While mountains grow slowly, surface environments can flip with startling speed. 10,000 years ago, the barren sand dunes of the Sahara Desert were a lush green savanna, populated with deep lakes and thriving wildlife. A slight shift in Earth's orbital axis triggered this transformation, reshaping the world's largest desert on a timeline far faster than typical continental drift. The maps we rely on are temporary snapshots. We live on a dynamic planetary engine where the ground is constantly shifting, independent of our attempts to define it.